As I said last class, my goal today is just to finish this stuff about modularity, and hopefully it won't take the whole period. It probably will not, because I'd rather you all go and spend a little more time on your papers. So if you get an extra half hour, that's a half hour more on your papers. All right. The other thing I wanted to say is this is our last Wednesday class of the semester. As I said originally in the syllabus day, the first half of the class is going to be looking a bit more at like foundational issues within cognitive science. And the second half, which should be a little bit more, I mean, honestly, it's going to be a little more fun. We'll be looking at applying philosophical topics, philosophical approaches to applying psychology research to classic philosophical topics like what is evil and things like that. So that's what we'll be talking about next time. Let me pin myself here. Spotlight for everybody. Okay. I'm very much looking forward to getting my second computer running again. All right. So the other thing to say, of course, is the paper is due Friday. If you sent me a draft, you should have gotten it back by now. If you need an extension, just ask. As I said last time, we're in a pandemic. I will not judge you. I do not care. If I could give myself an extension on grading them, I would. So like, I'm not going to be like very strict with this. I will not judge you, even if it's for something like I lost track of what day it was and I didn't start it. I'm not going to judge anything on this front. Like, really. Anything goes for this. So if you need an extension, just reach out. Even if it's on Friday, just let me know. And so just reach out and we're good to go. All right. Otherwise, you can turn in the papers on Blackboard. The Blackboard is up and running right now. Like the little Blackboard link, there's a link there that allows you to post it if you have any trouble with it, because also in typical CUNY fashion, we are having a CUNY first, like something or other over the next few days. And because of that, who knows if Blackboard's going to work. So if for some reason the Blackboard's not working, just email me a copy of your paper. That's totally fine. If you're just having trouble with the Blackboard, just email me a copy. That's totally fine. All right. So with that out of the way, the next thing I want to do is just power through these 4 questions and then go through 4, 5, 6, 7, and then say happy spring break, other than that stupid paper I have to give you all. So first off, what is the modularity of mind hypothesis? This is what we talked about last time. I just want to see if anybody can give me a general characterization of what the hypothesis is. Yeah, so Marie, the mind has parts. That is the first core of it. The modularity hypothesis is that the mind is not an undifferentiated whole, but it has parts. And then specifically, there's 2 different types of parts, according to the modularity of mind hypothesis. What are those 2 types? Give you a clue, look at questions 2 and 3.
So you have like the ones that are dedicated?
Yeah, there's these modules which are dedicated to particular sensory systems, and you have a central system or central cognition, which is more what we think of as thought. And so what is the job of the modules? What are they in charge of doing?
I guess each one is dedicated to like something special. Like one is for vision, one is for, I mean, the senses, I guess.
Yeah, the senses. It's basically each one is tied to a certain sense, and their goal is just to get information about the external world that is accurate and to acquire that information quickly and then give it to central cognition. And then once all this information is in central cognition, what is central cognition's job? What does it do?
It's more of like a deliberate thing. So yeah. it takes its time to process it and kind of give you a, I don't know.
Yeah, exactly. The central cognition does the things that we typically think of as thinking. It solves complex problems. It does math equations. It helps you plan a vacation. This is the stuff that is accessible to conscious thought that is really, this is really more what you think of as thinking. So in a certain sense, the processing that gets done by the modules is things like calculating where, so it turns a 2-dimensional array of light into a 3-dimensional picture of the room. So in some sense, for you, that just happens. You don't think to yourself like, oh, there must be this is a brown light here, so there must be a three-dimensional object. It's just, you open your eyes and boom, you get an experience, chair right there, desk right there, board right here. That's just, so central cognition is really the thing you think of as your mind or your thinking. And these modules are in charge of controlling the sensory systems. So each of the basic idea we talked about last time was that if these are what modules do, and this is what their goal is, to provide the system, the central system, with certain information about the external world, that a good module is going to be a certain way. It's going to have certain features. And so what Fodor was arguing is that when we actually look at human cognition or human perception and the perceptual systems, what we find is that not only are these features things that any good module would have if its goal is to provide information about the external world, but actual human perceptual systems meet these criteria. So the first one we talked about was domain specific. So what did domain specific mean?
Each one is specialized on a certain type of system.
Yeah, so each module only focuses on a certain area. So a domain is a specific location, and so each module is in charge of only that specific bit of information. So eyes deal with light, ears deal with sound, taste deals with, I don't know, saltiness and sweetness and molecular structure and other fun things. We also said, I switched these ones around. So we said it's mandatory. What did we mean by mandatory?
You can't turn it on and off.
Yeah, you can't turn it on and off. The only way you can stop the processing is by stopping feeding it information. If it gets that information, it will process it. So the moment you open your eyes, you see if there's any light to be seen. You can't be like, all right, I'm leaving my eyes open and now shut off. Same with your ears. The only way to stop yourself from hearing is put your fingers in your ears and yell loudly. So it's mandatory. The second one, or third one, is limited access by central cognition. So what did this mean? This was the thing I talked about with trying to remember the capital letters and the other stuff, and the colors on the clock face.
In my notes, I just have it as like memory being unreliable.
So it's kind of like memory being unreliable, but the idea, it's a little more than that. The idea is that clearly when I show you a clock with colored, like a colored face, on some level, some part of you has to be able to process the colors, because that's just like the color 6 on that clock was literally something like this. And like, if you did not process the color, you couldn't have seen the number 6. However, it seems like some of that information is getting processed inside the perceptual system or inside the module without ever passing that information on to central cognition. It's in the same way, like vision scientists have done some really fascinating and interesting studies on how vision works exactly. And what they've basically been able to come up with mathematical equations of how the human perceptual system turns a visual, like a two-dimensional experience of something into a three-dimensional experience of the world. Because as I said 2 classes ago, the light that hits our eyes is in 2D, and then the mind has to reconstruct the three-dimensional world that must have caused that 2D light array to hit the retina at the back of the eye. So in this case, what it seems like is the thing that does that processing, it collects a lot of information that it never passes on to central cognition. So things like you recognize a 6, and while your lower level thinking recognized that, oh, it was in black, when you yourself ask, what color was that? That is not accessible. All that got passed up was, oh, there was a number 6, or oh, there was this shape. So what Alan just asked is the Stroop test. Are people familiar with the Stroop test? Before I explain the Stroop test, let me see if I can pull up the Stroop test. just because I don't want to talk about it unless everyone knows what it is. So give me a second to see if I can find a good case Stroop test. All right. Open link in new tab. No, that's not what I want. Open image in new tab. All right, everyone ready for a sharing? I'm now going to share screen to the Stroop test. This is the Stroop test. How many people have seen this before? Basically, it's very easy to read the words in the top one, and it's very difficult to read the word, or no, it's very easy to say what color the top words are in, but it's very difficult to say what the lower words are in. So for instance, like you can just say blue, yellow, red, purple, black, simple, but yellow, well, you can try it yourself. And if it's typically a long test. So what this is actually suggesting is like, there's no reason consciously why this should be so hard, but really the explanation that's typically given for these things is that the information processing, because you're in charge of processing color and language at the same time, basically what happens is the modules interfere with each other. And so your language processing module and your regular vision color processing interrupt each other and get in the way. And you have, so when they're sending stuff up the higher cognition, it gets in the way of each other. And there are other cases of these sorts of what are called cross-modular effects or cross-modal effects. So that's closely tied in with this, but it's not quite the exact same. So does everyone, though, understand this limited access by cognition thing? We doing all right with this? All right. So informationally encapsulated. That's the next one. We haven't talked about this one yet. Informationally should be easy enough for everyone. What is informationally? It's the adjectival form of what word? Or I guess adverbial form of
Information.
Information, yeah. So information. So informationally encapsulated. Now, encapsulated. This is a really fancy way of saying, well, think about a capsule or a time capsule. What is a time capsule? Yeah, it contains stuff. And specifically, when it contains that stuff, does anything get in with that stuff? No. Does the stuff ever get out of the time capsule?
Not unless somebody opens it.
Yeah, not unless somebody opens it. So it's basically just an enclosed system. So what this is saying, informationally encapsulated, basically means that the information processing that goes on inside one of the modules cannot be affected by the outside. So the classic way of understanding this is to look at some illusions. And the reason why is the cool thing about visual illusions is you can know they are illusions. You can know that things are not the way you see them. And yet that conscious belief you have, that awareness, doesn't prevent you from still experiencing and seeing the illusion. So the idea with this is that the modules, I'm going to erase these questions now. The modules are basically, they're in charge of talking and spitting out outputs to central cognition, and they get it from things like the eye. So this is my beautiful eye. So the basic information goes here, this reconstructs and then spits information to central cognition. And the basic idea is that central cognition cannot go back this direction. It cannot reach in and tell the modules that it's doing something wrong. It can't say, hey, I know these things aren't what they appear to be. The module is still going to spit it out. It is informationally encapsulated. It cannot be penetrated by information coming from central cognition. So let's just play the fun game called Let's Look at Some Illusions. So the first illusion that I want to share is this famous one. So there's the zoom. I'm sure at some point you have seen the famous Muller-Lyer lines. So here's the Muller-Lyer lines. Come on, share. All right. Muller-Lyer lines. Do these look familiar to everybody? All right. So here's the question. You can either read the instructions on the side or just I'll tell you. Which line is longer? The one at the top or the one at the bottom? And by the line, I mean, ignore the arrowheads. Like if you include the arrowheads, the lines look like it's clear. Just concentrate on that central line, the thing between the arrowheads. Which one is longer? Well, first off, which one looks longer?
The bottom. I mean the top.
Yeah, the top looks longer to us. It like you cannot help but the top one looks longer. If you were asked, it looks longer. But of course, the trick is, in truth, they're the exact same length. They are identical in length. Now, you know they're identical in length. I just showed it to you. I can show it to you over and over again. And yet when I take away these lines, which one looks longer? Yeah. No matter what happens, the top one still is going to look longer. Your knowledge that they're the same length cannot penetrate into your visual system. It is unable to affect your experience. Does anyone, out of curiosity, no one quite knows why the Muller-Lyer illusion is a thing, but has anyone heard what some of the hypotheses are as to why we cannot help but see the top line is longer than the bottom line?
I would say maybe the top one looks more open, I guess, as opposed to the bottom one, which looks closed.
So that's along the right idea. And the reason why, and you're correct to speak in terms of open and closed, but the reason why it looks open and closed, if we scroll down, this is the most common place in which we see these sorts of lines. So if you look here at the red, maybe I can zoom in a little bit. If you look at the red and you just, I can't cover it. Here I am, like nobody can look at me. And here I am covering things on my monitor. But if you actually just look at these, if you were looking in a three-dimensional room, the farther wall or the farther thing would connect with the walls in the same way that the top line does. While the bottom line, which is closer to you, would look like the bottom line did in the original illusion. So it looks like what happens is we are designed to look at three-dimensional rooms. And so when we see something like this, our mind automatically processes this and cannot help. And there's actually been some evidence that people who grow up in houses that do not have like straight walls like this and do not live in what is generally called like a carpentered world, people who grow up in the rainforest generally are far less susceptible to this illusion. And it's an older experiment and there's been some question around it, but there is some evidence that people do not have this illusion quite as strong if they didn't grow up with walls like this, which suggests that something about these modules are learning, but they're learning in a way different from our regular learning. All right, the next one, illusory contours. When I change the tab, is there a new picture on the screen now?
Yep.
Okay, this one here. I can more or less see two triangles. Does everyone else share this with me? Like, it literally looks like it's brighter on top than it is behind with this top triangle. And yet, of course, what is the illusion? Are there any triangles here? Are there actually anything with, is there actually a white triangle on top? Is there actually a slightly darker triangle underneath? No, there's not. All that's on this page are some Pac-Men and some like acute angles. But of course, our mind sees this and automatically projects it. And even if we know that they're just Pac-Men and corners, we cannot help but see these sorts of things. So this is another classic case of the processing done by the visual system. Even if you know that it's an illusion, you cannot help but see it. So this is another case in which your modular processing, whatever's responsible for you experiencing these triangles, is encapsulated and cannot be affected by what's in your conscious or higher order brain. All right, the next one, we're going to go with the lilac chaser. So lilac chaser. This one will tell you the instructions. Hopefully it works. All right. All right. How many of you see the green dot? How many people saw the green dot? Do I need to do it again?
Could you do it again?
Yeah, I'll definitely do it again. Just stare right at that X and don't look away. Just stare at the X in the middle and then tell me if you see a green dot. It's kind of, it's not like perfectly green. It's almost like an aquamarine color. Do people see it? All right. So, of course, what's the illusion here? Well, now watch the same thing, but don't look at the X. Just like move your eyes around. Just move it around as it goes. Like try to focus on the green dot. Try to see it going. Like instead of looking at the X, just focus on the circles. Where, of course, is the illusion? Is there actually a green dot there?
No, it's just the circles disappear.
Yeah, there is no green dot there. Rather, what it actually is it's an after image caused by, so here's the actual science behind it. I'm not a vision scientist, so this isn't going to be the most in-depth explanation of this phenomenon. But the basic idea is that the way that light works and the way the eye sees is that in your mind, or the cells in your head are, some of them are, they're basically binary things. So once all the light comes in and at the back of the retina, it just sees in green, red, blue. But then there's cells here that are responsible for passing information along to the head. And the way these cells work is you have one set that are responsible for red and green, and another set that are responsible for blue and yellow. So because of this, what it means is that, and actually there's a third one that's responsible for black and white. And basically what happens is that when you are constantly looking at a certain colored object, what ends up happening is that the other side cells get or the ones responsible for this get overstimulated. So it's basically, if you stare at a blue image for a very long time, your cells responsible for seeing blue light get overworked and stop being able to work correctly. They're just too tired. And what this means is the cells that weren't doing anything, namely the yellow ones, will keep working normally, but the only information that gets to your gets processed is this yellow color. It is the only one you see. So if you stare at a red star for a very long time and then look at a white wall, you'll see just a green star on the wall. So in this lilac chaser, we're staring at an image and our cells that are responsible, because it's purple and green, or pink and green, it's actually using a couple different of these, which is part of the reason why it's so strong. But the basic idea is by looking at the pink circles, your red gets overworked, which just means as soon as that red goes away and it's white, the only cells that are firing are the green ones. So the only information, so the mind at the conscious level is just told, oh, there must be green there because that's the only information that's coming through because the red ones have gotten too tired to send any more information. If you didn't follow all that, that's fine. It's fascinating, but that's one of the main things of after images. That's also why if you stare at the sun and then look at a wall, you see like a big black dot. All of them are just about the way the mind works. And the key is, even if we know the green dot isn't there, we cannot help but see the green dot. The green dot is there and we can know. We can't tell our eyes, stop seeing that fake green dot. Stop seeing the fake green dot. That's what it means to be informationally encapsulated. And you can see why you'd want a system that deals with perception to be informationally encapsulated. Because remember the reason that we were talking about, what's the reason that we have these modules? Well, there would be evolutionary benefits. So what is the evolutionary benefit of having a visual system that's informationally encapsulated, or a hearing system that's informationally encapsulated? Why do we want this processing not to get affected by our beliefs and desires and other things? Anyone have any thoughts? Well, how many of you have often sat there in about, it's your last class before lunch, and what do you start daydreaming about? Food. Yeah, you're daydreaming about food and what you're going to eat. And imagine you're planning this beautiful meal and you're just imagining this beautiful meal. You might even picture it in your mind, like, I want to eat this thing. Now imagine if your belief or your desire to eat this thing could affect what you saw. What would happen? If you were thinking about this food so hard, what would you see in front of you? Yeah, you'd start seeing the food because if central cognition could talk to and affect the it would affect the modules and it would cause you to start hallucinating. It would cause you to start seeing things that aren't there. It would also, however, like lead to bigger problems. Like if your number one fear is to get murdered by serial killers and you start being scared of serial killers and you start hallucinating them, you're going to go crazy very quickly. Or if you just tell yourself there's no bears around here, there's no bears around here, there's no bears around here, and you'll walk into that bear. And yeah, exactly. Alan says when Wile E. Coyote sees Roadrunner as a ham. Exactly. That is not something that is ideal. We need accurate experiences of the world. If we saw what we wanted to see, we would not get around in the world very quickly because nothing we saw would ever, like, we'd never see a danger as a danger. If we saw a tiger, well, that would scare us. So why don't we just see it as like a happy puppy? And then we'd go over to pet the puppy and we'd get eaten. So that's the idea of why they're informationally encapsulated. It's also the idea behind mandatories. You want to make sure that this information, no matter how unpleasant, does get to higher cognition. Now, so does everyone understand what informationally encapsulated means in this context? Plus, I recommend just going on and looking at lots of fun illusions because illusions are a blast. But all right, the last three are fast, shallow output, fixed neural architecture. Fast is pretty straightforward. This is just fast in the same sense of fast as any other type of fast. It's just, it happens quickly. And this is also one of the easier ones to show. Let me see if I can actually find the mathematical, let's see. Let me close this for 1 second. Have the equation by which the eye sees in 3D. How do I see depth? Let's look at the mathematical equation. I'm trying to find something with just a whole lot of math numbers here. All right, this might not work. I could do one in terms of language, though, where, has anyone ever taken a linguistics class? So within linguistics, one of the main things that people have discovered is that the way to think of sentences is not in terms of strings of words, but in terms of these complex structures in which they have various different parts called like verb phrases, noun phrases. And so it's a really complicated thing. So when you hear the sentence, he went there, you might just think like, you immediately just get the meaning of it. But in order to get the meaning of that, your brain has to really process this entire complicated thing. And to see that your brain is processing in this way, you can tell by what are called garden path sentences. Have people heard of garden path sentences? Basically, what a garden path sentence is it's a sentence that it seems like your brain automatically processes it in one way, and then you get to the final word, and all of a sudden it all crashes down. So it's a sentence that's actually perfectly grammatical, and yet it's very difficult for us to see the grammaticality. And this is what shows just how complex the calculations are in the mind, and yet these modules do them. The old man, the boat. Yes, the old man, the boat. That's a great one. The old man, the boat. Does everyone see that this sentence is perfectly grammatical?
Yeah.
What is
I
the
think
grammatical meaning of this sentence?
old people like take care of the boats.
Yeah, old people work on the boat. But the first time you read it, you read the old man, and then you're like, huh, but that doesn't make sense. And the reason why is because your language module is doing this really complicated series of calculations. Here's another one.
How you doing?
That
What's in
people
there?
accumulates. That's another perfectly grammatical sentence,
Yeah.
but the first time you read it, it seems completely ungrammatical.
Hell no. I just want to speak to him on some
Grammatical
business
reading
shit.
of it?
He said he wanted to speak to you on some business. He wanted to speak on some business.
Yeah, I'm not sure whose
My name
mic
is
is
Izzy.
on. I'm just gonna.
You're not gonna know me though, but I'm a jeweler around here. I wanted to see, I just want to talk to him. But I mean,
Is that you?
He's a jeweler, he just wanted to talk to you.
All right. Can you hear me?
All right, and that's Gabby's son too in there?
you can tell him I'll be back.
No, are you looking for Bill, brother?
Yeah,
I can make you Bill. You wanna come inside?
that's what I came for.
Come along, though. I don't know who's outside.
Yeah.
Oh, no,
That's
he's
fine.
not with me.
That's fine.
He said he was back.
All right. Can people hear me again? All right. Perfect. So, fat people eat accumulates. This sentence here is perfectly grammatical. Can people get the grammatical reading of it? Otherwise, it just looks like complete word nonsense. Is anyone able to get what the grammatical reading of this sentence is?
Yeah.
What is the grammatical one?
Fat people eat accumulates. So like, I mean, obviously, you normally read it as fat people eat accumulates, but it's like the fat that you eat eventually.
Yeah, the fat that people eat accumulates in your veins. The most famous one and my actual personal favorite sentence in the English language, perfectly grammatical sentence, but it's almost impossible to get a grammatical reading of, is this classic one. Actually, I can never remember how to spell it. How do you spell the word buffalo? Like the city or the animal? Is it two L's or one L? Okay.
It's one
two
L and
F's,
two L.
one L. Okay. So here I go. This is my favorite English sentence. So that is buffalo 8 times is a grammatical sentence. Buffalo, 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 buffalo. Is technically a grammatical sentence of English. It basically means that bison from the city in upstate New York bully other bison from the city in upper New York who are bullied by bison in upper New York themselves bully even more bison from upstate New York. That's neither here nor there. But so what these sentences show and why I'm bringing them up is one, just because I wanted to talk about the buffalo sentence, and two, more importantly, they show that the calculations that are done to get grammaticality judgments and to do all of this are really complicated. Like but it strikes us as immediate. It strikes us as automatic that we're able to figure out these sentences. And most of the time, we don't have to piece them together. And you get this in the same way as with your eyes. The information that comes through your eyes, you open your eyes and you instantly see 3 dimensions. You instantly see color. So it's just the processing is incredibly, incredibly fast. All right, everyone on board with garden paths and that I took the garden path to explain that. But the basic idea is modules are fast, they process quickly, and that's the moral to the story. And part of the reason why they're so fast is because they're only operating on a small amount of information. If you're in charge of every part of the house or every part of the school, you wouldn't do very well if you were also planning particular, like There's a reason the president of CUNY is not in charge of designing my syllabus. All right, the last two, shallow outputs. The outputs that are being talked about here are the outputs between the modules and central cognition. So what is meant by a shallow output? Well, an output is just the thing that gets spit out of a system. So if the module's in charge of giving a view of the world, it then spits this information out to central cognition. To say that this information is shallow just means that it doesn't contain all the information about something. It only gives you some of the information about it. So for instance, this goes back to what we talked about a few classes ago. If you just, like your eyes, you're gonna automatically see something, but it's not gonna necessarily tell you what type of thing you're seeing. So if it's late at night and it's kind of dark, you can see something moving, but it's not necessarily gonna tell you what's moving. Or you might see a type of animal you've never seen before. So in some sense, you will get a clear image of this creature, but you won't know that it's a, I don't know, what's an animal we can go with here? What is an animal you don't see in New York much?
Raccoon.
Yeah, a raccoon or a possum. Let's go with a possum, an opossum or possum. So you might see a possum, but if you've never seen one before, your visual system doesn't tell you that it's a possum. In the same way with language, if you hear this sentence, in some sense, you know what it means. However, do you fully understand what the person who said this was trying to communicate? So what are they trying to say? Well, they're trying to say that he sat there. But what are some, do you know who sat there? No, this alone doesn't tell you who sat there. You also don't know where there is. So the output of the language, it tells you, yes, this is grammatical. It tells you generally like, these are the sorts of things that could be like, whatever the person is somebody that identifies as a man. And there is a physical spot that they sat. But the language system, it doesn't tell you that information. It gives you something shallower. It just tells you that it's someone identifies as a man and somebody who's sitting there. Like there's a space in which they sit and it's probably farther away than here. So that's the only information that spits out. Same with sound. If you hear a gunshot ring out, you hear a loud boom sound, but your ears themselves don't tell you whether it was a gunshot versus a cannon shot versus somebody dropping some metal that makes a loud clash. So does everyone understand this last bit, the shallow outputs? All right. Any questions on any of these first six before I do the last one? All right, fixed neural architecture. I think there's an eighth one, but I don't really feel like talking about it because I want to send you all on your way and just talk about the fixed neural architecture. So with the fixed neural architecture, I actually wanted to bring this one up because it does show a way in which the sorts of, just because we take kind of a Fodorian folk science, folk psychology, yay sort of approach, there are beliefs, there are desires, that doesn't mean that there's nothing to be said about neuroscience and there's nothing to be learned from neuroscience, because it does seem like parts of the brain correspond to certain types of reasoning or certain types of processing. And specifically, what we find is that with most of these modular systems, there's a very particular part of the brain that is associated with that processing, which is what you'd expect if it was a modular system. Because if a modular system is in charge of just looking at a particular domain, it's only looking at a specific domain, then it's probably going to want to be able to think more quickly or process information more quickly, which probably means the neurons which are associated with that thinking are going to be close together and clustered in a particular spot in the brain. And what we find is that with most modular systems, or most of the most of the things that we hypothesize are carried out by modules are associated with very particular parts of the brain. And so things like when I drew that terrible brain in the second class or maybe the first class, it is the case that like the eyes, like it's back here. Like this is the part of the brain that deals with vision. Hearing, there's another very particular part of the brain. So it does look like a system that was designed well. Well, a system that was designed well, the modules would be associated with a particular part of the physical neural structure underlying the thinking, underlying that processing. And when we actually look at it, it looks like that is the case. It looks like the things that we hypothesize are modular are associated with fixed neural architecture. So the payoff of this is supposed to be like, hey, when we actually think, it does look like our mind is split up into these two different types of processing systems. There's these central ones that operate with large amounts of information, and any belief on one thing can be used to influence a belief on another area. Meanwhile, there are these closed modules that only work on certain types of information very quickly at high speed, giving shallow outputs that can then be used by central cognition to do useful things, but which cannot themselves be affected by central cognition. So does everyone understand like the general gist of what it's supposed to look like, and then how the fact that we see with actual human vision and human hearing and everything else, that they do seem to meet all of these criteria, which strongly suggests that there really are modules governing these sorts of things. So does this make sense to everyone, how the general gist of this argument works? All right. Now, why the hell should you care about modularity in particular? Well, we said at the first class of talking about modularity that whether there are parts has a lot of interesting consequences for understanding the mind, because if there are different parts that operate differently, we're going to expect them to break down in different ways. We're going to expect them to have different effects on things like mental health. And so just to highlight some of the modularity stuff that has implications is there's certain questions around things like what is actually calculated in the modules. But if there's certain sorts of things, like amongst other things calculated inside the visual module are facial expressions like this. So if you see this facial expression, you automatically process it as rage. Well, that has implications for how much somebody could change your mind about the fact they're mad. Maybe if they're making this face, other people are automatically going to treat them as angry and are going to get their backs up. So this is something like, here's a practical implication. If we see emotional facial expressions and we cannot help but see them as this person is mad, it's going to it's going to influence things like how we interact with this person in a fight. If we see them coming here and they make an angry face, even jokingly, it might put us on the defensive. And even if we know, like they tell us, I'm only joking, I didn't mean to make an angry face. The fact that you saw that and processed it and sent it to central cognition means you cannot help but have seen it this way, and it might affect how you interact with them. Other things are sorts of things around, there might be a case to be made that certain types of biases are built into the modular systems, and whether things around, is there a sense of, like, is it the case that when somebody is racist, they literally see the world in a racist way? Because if that's the case, that people literally see, like, the way they have learned to see is to see people of color as lesser, then teaching them that this is the case isn't going to work, because if that stuff is modular, then it's not the sort of thing that could be taught to someone. If they've literally just been conditioned by growing up in a racist family to see racistly, then we're not going to be able to tell them anything. If, however, there's evidence that a racist and another person has the same visual processing, and the only difference occurs at the cognitive level, then it should be possible to teach people to stop being racist and give them explanations. And it might not be easy, but it's something which would in principle be possible. So even though this is kind of an esoteric sort of topic, this idea of does the mind have parts, it is something that in psychology and more generally has practical implications. All right, are there any more questions on this stuff? Any more at all? All right. In that case, I have nothing more I want to say on modularity. As I said at the beginning of class, for those of you who arrived late, this is our last Wednesday class of the semester. After the break, we will be meeting once a week. So yeah, we're only going to be meeting once a week, Alan. There will be bonus videos certain weeks, and if you really wanted to meet with me, you can, but we will be meeting once a week because, well, let me shut off the recording.